In the last episode, we learned what is constructor, a special method in Java that runs automatically when we create an object. It helps to set the initial values like name, age, price, right when the object is born. And it's four types of constructor. Default constructor. We saw that if we don't write any constructor, Java secretly adds one default one. It has no parameters and just creates a basics object. Second one, no argument constructor. We wrote a constructor with empty brackets, no parameters. It let us assign default values manually inside the constructor. Third type of constructors, parameterized constructor. This one takes input while creating the object like name, age. It sets values directly in one step. Lastly, copy constructor. Java doesn't have it by default, so we create one ourselves. It let us copy all values from the one object in another, like cloning. Alright, now that we know the types of constructor, today we are going to put that knowledge into action by solving a real HackerRank problem using constructor overloading in Java. What is constructor overloading? Same constructor name, different parameters. Constructor overloading means you can have multiple constructors inside the same class, but each one must take different set of inputs, so Java knows which one to run based on what you pass. Each version handles different situation. Let's say you only have the character's name. You use the constructor with one input. If you also know the role and level, use the full one. It's like ordering a food, small, medium, large. You pick based on your need. Java chooses based on the arguments. You don't need to tell Java which constructor use. It automatically selects the correct one by checking how many values you pass. If you pass one values, it calls the one parameter constructor. Pass 3, it calls full version. Cleaner and readable object creation. Without constructor overloading, we'd have to write one giant constructor or set values one by one later. This makes our code shorter, neater, and easier to understand, especially when creating many objects. So, in short, constructor overloading means we write multiple constructors with different inputs, but the same class name. Java handles the rest. Alright, let's take all the constructor knowledge and jump into real coding challenge on HackerRank. We will solve a character creation system using constructor overloading. And let's go. We'll start from problem statement. You are tasked with developing a character creation system for a video game. Let's imagine we're game developers and we need to build a system where user can create their own characters like Zelda, Mario, and anyone. The system should allow players to create their in-game characters with different attributes. These characters won't be blank. They'll have their own attributes like role and level. So we need to accept input and store those values inside the characters. Each character is defined by their name, class, and level. Every character needs three things: a name like Zelda, a class or role like princess, warrior, mage, and a level which tells how experienced the character is. Develop a Java program that demonstrates the use of constructor overloading. Now comes the twist. We have to solve this using constructor overloading. That means writing two constructors inside the class, one full and one partial, to create character objects with different sets of attributes. In some cases, we'll get name and role with level. In other cases, just name. Our constructor should handle both situations smartly. And requirements they gave like this. Implement a character class with the following attributes. So, first we need to create a class called character. This class will hold all the information for each player we create in the game. Name, string data type, representing the name of the character. The first property is name, which will be a string. This is just a character name like Mario or Zelda. Character class string, representing the class or profession of character. The second property is character class, again a string. This means what type of character it is, like warrior, mage, or princess. Level, which is int data type, representing the level of character. And the last property is level, which is an int. This shows how powerful or experienced the character is, like level 12 or level 0. Implement constructor overloading to initialize character objects. Now here's the actual logic part. We must use constructor overloading. That means one constructor will take all three values like name, role, level. Another will take only the name and automatically set the rest. Create a default constructor where characters with roles default to unknown and the level defaults to 0. And if someone just type the name, like only Mario, then our constructors should still work. We should set the role as unknown and the level as 0 by default. Alright, so input is super simple. The user enters one line of text where all the details are space separated like this. Here's the catch. To pass all the test cases, you must use constructor overloading properly and print the output in the exact same format. Even a small changes like lowercase or missing colon will fail the test. And want the output in 3 separate lines like this. No extra spaces, no missing columns. Check both test case they gave us. Input 1. All 3 values are given, so we use the full constructor here. Only name is given. We use the overloaded constructor. Default role becomes unknown, becomes 0. So we'll write the logic in such a way that handles both inputs. Our plan is simple. When to use which constructor? We'll first take input using scanner like we always do in Java. Next, we split the input by space to separate names, role and level. If we get 3 parts, name, role and level, we call the constructor with all values. But if we get only one part, just the name, we'll call the other constructor with default value. We'll use that constructor call to create our character object and store it in variable like player. Finally, we'll call player.display method to show the name, role and level just like the sample output. So, in this entire logic is based on just one thing, how many words the user gives in input that decide which constructor gets called. Alright, let's now write the full code step by step and I'll explain every line clearly so you understand how constructor overloading is applied in real coding rounds. Let's start by creating a class named character. This class will act like a blueprint to create a game characters. We define 3 fields, name which is stores the character name and character class stores their role like warrior or mage and level represent the character's game level. This field will belong to every object we create from this class. Now, we create the first constructor, the one that takes all 3 values from the user. This dot name is equals to name. This assigns the input name to the class own name variable. Same for character class and level. We use this keyword for refer to the current object's variable. This constructor will run when the user provides the complete input, name, role with the level. Let's now create the overloaded constructor. This one runs when the player gives only the name, nothing else. We assign the name normally and for the rest we give defaults. So, if a player just enters Mario, the role becomes unknown and the level becomes 0. Let's create one last method called display. This will print out the character details in the exact format which given in HackerRank. Each line prints one value with a label like name followed by the variable. This method helps us to see the object's data clearly and it keep our main method clean too. Now we write our main method. This is where the program actually starting running. And Java always start with this method, public static void main. First, we create a scanner to read input from the user. Then we read the entire line into input line. Alright, now let's break this line down. String parts means we are creating an array of strings. Basically, a list where each word will go into a separate slot. Then we write input line dot split inside the space. This means take the input line and split it wherever there is a space. So for example, if the user types Zelda space princess space 12, this line will break into 3 pieces. So in the first index, parts 0, Zelda, it will stores, and parts 1 stores princess, parts 2 it will stores 12. That's how we capture the name, role and level separately. And this is super useful whenever we want to break a single line of input into multiple values, especially in coding platforms like HackerRank, where everything's come in one line. Now, we declare a character type variable called player. We'll assign it later based on how many values were given. If the input contains 3 values, that means the user gave name, role and level. We extract each values using index position. 0 index for name, and one for role, second index for level. We convert the last one into int using integer dot parseInt because it's string by default. Then we use our full constructor with all three values. Otherwise, only name was entered. So we'll use the overloaded constructor that fills the rest with the default value. We just pass the name to new character bracket open and name inside. The rest will be handled inside the class. Finally, we print the result using our display method. This will show the character's name, role and level, exact as expected output is in HackerRank. And one more last tip, make sure there is no extra space, no missing line, and all labels start with uppercase. This is HackerRank, so formatting matters. Even one missing space can break your test cases. Let's see what actually happened when we ran the program. Say, we type this input. It's what actually Java did step by step. It reads the entire line using scanner. Then it split the line into three parts. Name is equals to Zelda, role is equals to princess, level is equals to 12. Since we had three values, it used the parameters constructor. So the object player was created like this. Then it called display method and printed this. Now look at the second test case. Java split this into just one part, the name. So it used the second constructor, the one with only name. It assigned row is equals to unknown and level is equals to 0, and output was like this. This shows how constructor overloading adapts based on the input. No need for if else, scattered all over the place. So instead of writing multiple setup methods or hard coding defaults, we use constructor overloading. Alright, we've now seen how constructor overloading makes your Java code flexible. One class, multiple ways to create powerful objects. But this is just one part of bigger puzzle. In the next episode, we're jumping into something equally powerful, method overloading. Same method name, different logic. If this video helped you, leave a like. It really supports the effort. And hey, if you got stuck somewhere, drop a comment. I read them all, and I'll try to reply to as many as I can. Notes, always linked in the description below. That's all for now. Until then, signing off, Chad.